In this video, I'm going to go over reading trig graphs for the IB Math SL exam. There are some commonly asked concepts on trigonometry graphs, so sine and cosine waves typically. So I'll just do 3 examples here to illustrate those. And these are pretty simple examples. These are not going to be the most complex ones, or these might be a small part of a longer question. So here's an example. They give us the graph of a function. It's not clear if it's a sine or a cosine wave just from looking at the function on the graph. It's never clear. They have to give you more information in the question for you to know if it's a sine or cosine wave. So here they're telling us that the function is of the form y equals p cosine qx. So I know it is a cosine wave. And I'm asked to write down the value of p, calculate the value of q. So the command word write down means the information I need in order to find p is staring me in the face. It's right there on the page somewhere, and I just have to pull it out and write it down. So it should be a very quick question, usually a 1-point question, that you don't want to find yourself calculating or overthinking. So a write down the value of p, if I'm looking at where p appears in the function that they've spelled out, it's y equals p cosine. That means that the p is like where I would put an A usually if I was writing this thing in symbolic form. An A sort of standing for amplitude or a scale factor. It's the thing you're multiplying by the function. So from the graph of a cosine wave or a sine wave, the amplitude of the graph goes from the midline to the top, or from the bottom to the midline. It's going to be the same. And so first you want to establish where your midline is. Here it's clear that the midline is at 0 because the top points are at 8 and the bottom points are at -8. So 0 is the midline. The top of each wave is 8, which means that the amplitude of the wave is 8. And then the p-value here is going to be 8, but we have to consider whether it's negative or positive. So I know that p is going to equal either +8 or -8. It's going to be +8 if this is a positive cosine wave. It's going to be -8 if this is a reflected cosine wave. So what we have to remember for that is that cosine waves start at the top. And since this function does start at the top, meaning on the y-axis, it's at the top of the wave, and there's no horizontal translation in this function, meaning it hasn't been slid over to the right or left, then I know that this actually is a positive cosine function, because if it was a negative cosine function, it would have started down at the bottom and then gone up and then come back down. That would be a negative cosine wave. So this is a positive cosine wave, so because the amplitude is 8, the p-value is 8. And then the second part, part B, asks us to calculate the value of q. So this is going to require a little bit of work because the command word is calculate. So I'm going to group the q and x in parentheses there. It's easier to see it that way. It's the cosine of q times x. So q is the coefficient of x. I would normally put b there if I was writing this in symbolic form. They're using q. The letters don't matter. But what is important to know is that you can't see q on the graph. So p we could see on the graph. Q you cannot see on the graph. And I'm talking about q as the coefficient of x. What you can see from the graph is the period of this wave. And we should know that. Here I usually put the letter b. So when I write the formula period equals 2 pi over b, this might be how you learned it as well, you can substitute that b out for q, because that's what they're using here. And we're going to have to solve for that q by filling in the period of this function, which we should be able to see from the graph. Right, so the normal period of cosine is 2 pi. That's why the formula is as such. But the period of this cosine wave that we're looking at is not 2 pi anymore. So a period would be how long it takes horizontally to complete one cycle of this wave. It's not actually clear from this graph because if you imagine that the wave is starting here, it returns to its starting point here. Right, that would be one full wave cycle to go all the way to the bottom, back up to the top, and it's not clear what that lines up with. This is a little bit of a trickier one. To read the period from this graph, we have to appreciate the fact that it's going another wave and another wave, all before it reaches pi. And that is clear to read from the graph. I've now written all over the top of it, so it's going to be a little hard to see. Let me erase some of this. So you can see that this lines up right above pi, which means it's doing 3 periods in a pi. That means a single period must be pi thirds, or pi divided by 3, so that each one of these takes pi over 3 to do. That's how you get 3 in a single pi. So then pi over 3 equals 2 pi over q, because we had period equals 2 pi over q, and now I know the period is pi over 3. Could cross multiply to solve this. Q times pi equals 6 times pi. Therefore, q equals 6. Divide both sides by pi and it will cancel out. So that's the calculation for q that's required here. See if we can practice it again. So this next one, this graph has the equation y equals a sine bx, and now there's also a plus c at the end. So again, they've changed the letters. The letters don't matter. It's the position of the letters in the function that matters. We're supposed to enter the correct values for a, b, and c. So looking at the wave, I only know it's sine because they tell me it's a sine wave. And now I have an a value that is really easy to pull out from the graph. The c value you can also see from the graph. It's just going to be the b value that, again, we'll have to calculate. So in order to figure out a, the amplitude, remember you want to establish where your midline is first. To me, it's clear here that it's at 1 because I see the highest point is at 3 and the lowest point is at -1. So the midline is at 1, highest point is at 3, which means the amplitude of this wave is 2. And since the amplitude is 2, that means my a value in the function is either going to be +2 or -2. I just have to decide if this is a positive sine wave or negative. And indeed, because it starts at the middle and goes up, that makes this a positive sine wave. That's what sine waves are supposed to do. The parent sine wave function starts at its middle and goes up. So if it had started at the middle and gone down, that would be a negative sine wave. This one's positive, so a is 2. The c value is the vertical translation. So the c value here is, since the sine wave normally goes up and down at 0, so it would start at 0 and go up to 1, and then come back to 0, and then go down to -1. So since this whole thing has shifted up to a midline of 1, then that c value must be 1. So that constant that's added at the end of the function, that's going to be your midline. If it's negative, that's because the graph was shifted down. And then the very last thing is to calculate b. Calculating b requires that we know the formula period equals 2 pi over b. That b is just a placeholder for whatever the coefficient of x is. Remember, in the previous example, it was q. Here it's b. And I can't see it from the graph. What I can see is the period. So to complete one cycle of this wave, I'm starting at the middle, going up, going down, and coming back to the middle. So that's one wave cycle, and it took a pi to do it. So this is pi equals 2 pi over b. Cross multiply to solve. b pi equals 2 pi. So b equals 2. And perhaps one more that tests similar concepts. Here we have a function, looks like a very complicated question, but in fact it's quite easy. They're giving us the fact that it's a sine wave here, asking us to find a and b. And they're labeling the max and min points for us. So we can see we should be able to calculate the midline based on that max and min. So since you know the top point is at 10 and the bottom point is at 4, the midline must be at 7. So there's the midline of the graph, which means from the function, this b value must be 7. Since a sine wave normally has a +0 and midline is 0, this one's at 7, so b is 7. And then the capital A, that's in front of the sine function, so it corresponds with the amplitude of the function. We check the amplitude, midline to top, it's 3. We just have to double check whether it's going to be a +3 or a -3. And because this is a sine wave that starts out by rising, it is indeed a +3. And that is all.